Well, good morning. I am Santi Roca-Fàbrega, and I am working in the study of large-scale structure of the galaxy using n-body simulations. The large-scale structures are rings, bar, and spiral arms in galaxies, and the n-body simulations are similar to the ones presented in the talk before. The question is why we are using n-body simulations. Well, we are using n-body simulations because, well, yes, I need this, thank you. We are using n-body simulations because the observations are not good enough to study these large-scale structures. Why? In our galaxy, in the Milky Way, the problem is that we have a lot of dust and gas blocking the light from the disk, which is the place where the large-scale structures are. And in the external galaxies, the problem we have is that although we can see if the galaxies face on perfectly well the bar, the spiral arms, and all the structure, the problem is that they are so far that we cannot study the stars individually, and then we cannot see the kinematical properties of these stars, and we cannot see how the large-scale structures are moving. The other thing is, if we want to make an analytical approach, the problem is that we have no general expression for the potential in the galaxies. We can only do some approximations like this one, which is to call a global potential for the galaxy as a summation of the different parts of the galaxy. For example, a summation of the dark matter halo, the disk, the bulge, the spiral arms, the bars, etc. This has also the problem that it's not time dependent. Then we cannot study the formation and the evolution of the structures. This thing, this potential, this analytical potential can be used for one simulations which are less good than the n-body simulations, which are the test particle simulations, where we fix this analytical potential, we put some particles, and these particles are moving only filling this potential, and at the end they are relaxed to that potential, and we can try to find the properties of the stars due to the presence of the bars and the spirals and all that. But well, we want to use something more realistic, which are the n-body simulations. And we have two approaches. The first approach we have is a pure n-body simulation, a simulation where we have only gravity. We solve the Poisson equation in each part of the simulation, and we can see how the structures are evolving. For example, in that case, what we do is a small box, we put inside the initial parameters for a more or less realistic galaxy without a structure, and we let it evolve. And at the end, as you can see, we obtain bars and spirals, and we can study how they have been formed and how the particles in the n-body simulations are affected by these structures. The problem with this is that we have no gas, and the gas is something really important in galaxies because there are lots of processes where the gas is involved. Then that's a big problem of that simulations. And the other problem is the resolution. We cannot see things inner than this 1 kiloparsec in distance. We cannot see the processes that are happening with a dynamical time smaller than this 10 to the 3 years, and we cannot see what happens with the stars properly because each particle in the simulation is a particle with 10 to the 3 solar masses. A second approach we have is cosmological box simulations. In these simulations we have the gravity, and we also added the gas component. And then we solve the Poisson equations for the gravity and also the hydrodynamical equations for the gas. And the idea of these simulations is to put a really big cosmological box with the primordial density fluctuations. We let these density fluctuations collapse, form dark matter halos. The baryons cool down inside the halos. These baryons starts the star formation, and at the end, at redshift 0, we obtain realistic galaxies, and we can study the formation of large-scale structures due to the mergers, due to the interaction with other galaxies, what we cannot do with the other simulation, which is an isolated galaxy simulation. In the case, the problem is that we cannot understand exactly all the physical processes, for example, the star formation, and all that we need to know for that simulations, and also that the resolution, the spatial resolution, needs to be much bigger because we have a bigger box. Well, some results we obtained is that we found that several different structures, several different spiral arms are present in galaxies. For example, we have spiral arms rotating like a rigid body when a bar is present in the center of the galaxy, but we have spiral arms rotating in a differential rotation if the galaxy has not bar. We have also seen that we can find the co-rotation, the place where the structures and the disk are rotating at the same speed, only taking into account the kinematics of the stars. And we also seen some special galaxy that has 2 bars misaligned in the case of hydrodynamical simulations. And well, that's all. It's published. If you want to see it, you can go to the archive. Thank you.